So next step is choosing the algorithm or choosing any machine learning model on which you want to work and create model for your particular requirement. So once we have collected the data, cleaned the data, and we have seen that yes, there is a sensible relation in the data, next thing comes that which algorithm we should choose that is serving our objective. Choosing the right algorithm depends on the problem type and the data characteristics. So for example, let's say if you are trying to identify a customer who is going to leave, you might have to work with a different algorithm. If you are going to suggest a movie to your customer, you might have to use a different algorithm. And if you want to use that, what are the cancer probability for a type of customer, you might have to use different type of algorithms. So for that, you have to understand the characteristics of the problems plus characteristics of these algorithms also, which is fitting into your particular requirement. Every algorithm is not used everywhere, and every data is cannot be used with every algorithm you have. So there are different kind of requirements like recommendation, regression, clustering, classification, and there are different techniques like logical regression, decision trees, SVM, KNN, random forest, and naive Bayes. So we have to understand like what is our requirement, what we are trying to achieve. So when we are selecting our model or we are selecting our algorithms, then we have to focus on accuracy and interpretability. Accuracy and interpretability is like the results are accurate, but you are not able to understand those results. So basically accuracy is there, but interpretability is not there. If results are not accurate but you can easily understand, then also your model is not serving purpose, because you can understand the results but those are not correct results. Good model should have a right balance of accuracy and interpretability both. For instance, that a random forest may offer you high accuracy but the results are very harder to interpret in your case. In some other case it might be a best match. Other hand, the logistic regression model is more transparent, but it might not perform well in your case. So while you are selecting the algorithm or model, you have to see that the result should be accurate plus interpretable. And then the next thing that you have to see when you are selecting any machine learning model, what is the computational efficiency. So it's not necessary that your model has to work on very huge data all the times. Sometimes it might be little fast if the requirement is not too complex, and lightweight. And sometimes if requirement is complex, it might have to depend on the huge training data to predict the outcome. So you have to see like what type of problem you are encountering and which type of algorithm you are using, right? So if I just give you one example, so like same kind of problem can be solved by deep learning models that can be very powerful and need lot of memory and time for processing. That same problem can be solved by using simple models like linear regression or decision tree, and it can give you a faster result with very less memory consumption. So you have to see this balance also when you are selecting your model or algorithms. All right.